Hi, everyone. My name is Olga Pawluczyk, and I'm the CEO of PNP Optica. And today I'm hoping to tell you a little bit more about finding foreign materials through application of multi-hurdle inspection process. As a scientist, I always like to start with the basics. So I do want to cover a little bit more about what it actually means to detect foreign materials, and then talk a little bit about vision systems, which are relatively new to the market methodologies of finding foreign materials. So when you think about detection, it's not just seeing something, it's also making a decision. Did something occur? What can I measure? How can I measure it? And oftentimes when you consider something like, well, do you want to find out if you're sick or not? You have the opportunity to kind of be yes or no answer. And a lot of detection in foreign materials is a yes or no answer. Is this chicken or is this not chicken, really? So you assume that you have only two possible outcomes. But statisticians like to play with us and actually have four possible outcomes. And what's interesting is looking around those things that we don't think about. So if I detect, is there actually a detection going on? So do I have true positive or detection happen? Or do I have fake true detection, which is false positive? So my machine says it's there, but it's actually nothing is there. On the negative side, though, it's even more complicated because you assume, well, I didn't detect, it's all fine. So you have true negative, but you can also have a false negative where there was something there and you didn't find it. And if you think about foreign materials, and we've been running our systems in multiple plants now over a year, a typical plant that's well maintained will have what, 60,000 pounds an hour to 20,000 pounds an hour per line. And that line, if it has one foreign material a day, it's actually kind of statistically what happens, right? So in a week, maybe a plant will have 3-4 foreign materials. So you're running hundreds of thousands of pounds of product and you have one speck that you have to find. So having false negatives is what you want to avoid, but you also don't want to reject too much product. And that balance between I detect true product and I reject only a little bit of clean product is what everybody is striving to maintain. Does that make sense? So I always find that fascinating. Like when you think about it, it's billions of events that you're trying to ignore and find one event in a day, right? So when we're looking at detection, it's not only about, there's nothing like actual 100% detection. There is a statistical probability that you will find something. And obviously, in most detections, the smaller an object is, the more difficult it is to detect 100% of the time. So any machine can detect an elephant, but very few machines can detect an eyelash. Does that mean? That's kind of where the statistics come in. So when you're comparing detection methods, you have to know, can they detect what I want to see? How small things can they find? And how often, what's the probability of detection when those small things are occurring? And then you have to also think about, am I rejecting material that I don't want to reject? So in most of cases, our customers really want us to make those trade-offs. And oftentimes we have these discussions, like, well, what do you mean you can't detect 100% of the time? Well, we can. There is a perfect detection exists. If I reject 100% of your material, reject everything you put in front of me, I am a perfect detector. I found 100% of your bad things. Do you want to buy a machine like that? I wouldn't, right? So again, anytime you talk to a detection company, I don't care if it's me or somebody else, if they tell you they can do 100% detection, they're lying to you. So that's bad news, Ola. What's the good news? Well, right now you have a lot of technologies available to you. And we're starting to see a lot of our customers are applying multi-hurdle technologies, multi-hurdle detection to find foreign objects. So what are X-rays good at? Well, X-rays are really good at high-density materials embedded in things. So you have some metal embedded in your chicken nugget, X-rays will find it. A vision system, just like my eyeballs, cannot see through things. So therefore, a vision system will not find an embedded object. But a vision system can find things like cardboard and paper that X-ray machine essentially renders it invisible because it's low density. So you have metal detection and embedded detection with X-rays. You add a metal detector on top of it just in case somebody tossed a tool in there. And then you have a vision system and you hope to find everything that there is to find. Just like when you go to a doctor and, if your bone is broken and it hurts, it's pretty easy to detect. But if you have pain and there is no fracture in your bone, you will go into MR or ultrasound. It's the same story in our plants. The other thing to think about is what can detection methodology see, right? So resolution, for example, is something that's important. How small is the pixel that I can see with my camera? Well, then my assumption would be I can find an object as small as a pixel. Well, actually, that's not true. What if the object falls between 2 pixels? So you actually need 2 pixels to detect any object. So if somebody says, oh, I have a resolution of 2 millimeters, and that's my pixel size, actually you can only find a 4 millimeter object with that detector. Lighting. So with X-rays, you have a light, essentially an X-ray source. So if you have a very thick product, you have to turn it right up and shoot a lot of X-rays through the product. Then you have a thin product coming in through the same X-ray machine, you will oversaturate the detector. Same thing with a vision system. You crank up the light because you're expecting dark objects, and then you have white paper going through, just like with your iPhone. The picture will not contain sufficient information for a smart machine system to detect it. And this is one of my favorite things, and I think a lot of us forget about this. It's super easy to find a ball of metal, 0.8 millimeters, when it's presented on a cardboard box at exactly the height that the X-ray is supposed to work on. Add a whole bunch of different density materials to that issue. X-rays, just like your eyes, get confused, and vision systems get confused. So complexity of your background, or what we call noise and contrast, is also important. So is your product uniform? Is it, always the same color and doesn't have too much variability in there? It's very important. Height of the product matters for X-rays and for vision systems. And then finally, kind of the noise. What else is going on in the plant, right? If you have strong electromagnetic interference close to an X-ray machine, it will not work as well as if it was in an empty room. With vision systems, again, if you have light that interferes with the light you're shining at an object, it might spoil the detection. And my favorite aspect of this is, well, humans are really good detectors, are they not? I have seen somebody pick up, a fraction of an eyelash out of a stream. But they literally do miss the shovel, right? Like every single plant I visit has a story where something big went through and the inspectors didn't see it. Why? Because of this plot. So this is a plot established by the aviation industry. inspecting of fuselage, plane fuselage, before it's assembled. So pretty high stakes job, right? Like if the fuselage has cracks in it, people die, right? So these inspectors in the first 10 minutes of inspection task can detect 90% of issues. By the time they spend 30 minutes on the same task, they detect 50% of the issues. And then you can see what happens when they spend over an hour. So yes, if you poke Joe, he might find the eyelash, but then he's talking to Bob, right? And this is what happens with humans. So automation right now is at the level where we are not as good as humans in finding visual cues, but we're better than humans after 30 minutes at task. We're repeatable, we don't get tired, and we don't get hangovers on Mondays. So my company, PNP, does hyperspectral imaging. And you might ask, what is that, right? Like it is a vision application, but instead of looking at kind of 3 colors of light like we do with our cameras, we see hundreds of colors of light. And if you've done your science course in high school, you will remember that light is a particle in a wave. It has a given energy. If it bounces off material, that material, depending on what molecular and atomic bonds it has, will absorb the light or bounce it off the compound. So by knowing exactly what we're shining on the product and measuring exactly each wavelength that bounces off, we can tell chemistry of the product that we're looking at. And why is that important? Your eyes are actually spectrometers, but they're very poor spectrometers because they only see 3 colors. So we can only, well, grass is green, and I know that chlorophyll oftentimes will absorb green. Okay, that's maybe it's grass. Grass is maybe real. If you have hundreds of wavelengths, you can now see the same, green grass, but because you also know that, hey, that peak here is possibly plastic, this is fake turf and this is real turf. So even though they're both green, other peaks in other wavelengths will give us an idea whether it's something else. It's not grass, it's plastic. So with our technology, when we look at chicken meat and we see a white speck on it, we can say that's fat as opposed to that's plastic. And sometimes if we see something that looks exactly the same, so like that wet cardboard you sometimes get when people defrost chicken and you toss it on and you have like a piece of cardboard and nobody can see it. Well, for us, cardboard and chicken, even though the color to our eyes are the same, we see hundreds of wavelengths, we see the difference, and it looks like a Christmas light to us, whereas you can't see it. So, and this is an illustration kind of what happens when you're looking at something like a chicken nugget with a foreign object with normal cameras. You see 3 colors, so you kind of go, well, it looks different enough. It is definitely a foreign object, but you actually can't see, or very difficult to see, these little specks here, right? So those are the camera systems. And now you have, what if I just started looking at maybe 7 or 10 pixels of wavelengths, and now look at more differences. So now you can start seeing a couple of more objects because they look different than the background. And then what happens if I see hundreds of wavelengths? All the foreign objects are very well delineated. And not only can I tell you that they're not chicken, based on those spectral squiggles, I can tell you what kind of material they are. So hyperspectral technology can see any unknown material, and then as you train it using artificial intelligence and models and whatnot, you can start classifying the material And if you are very good with certain materials, you can actually tell exactly which material it is. It's the belt from machine down the road, or it's a belt from our facility. So this is kind of a couple of examples. So what does this mean to a plant? And this is one of our earliest deployments. So the system has been running around a year and a half now. And you can see that, I really love this, it's scanned. So this particular customer has had 0 downstream events after using X-rays and vision system to detect foreign objects. We found some. We find a couple a week, but nowhere in their plant has anybody found a foreign object afterwards. And this is kind of, all of you have your favorite bag of crud you find in your plant. This is my favorite test. You all come in with a bag of stuff and then ask me, can you find it? Yes, I might not be able to classify it right away, but I can find that something is not chicken. And, we can find very small things, very odd things. This is a little piece of plastic glove that we can find real time. This here, you can see the eagle-eyed here can see maybe the cardboard sample. Cartilage, again, looks very much like chicken. We were able to find hair follicles and cartilage. We actually, frankly, we kind of stopped production because our customer didn't know what to do about this, because they didn't expect to find hair follicles, feather follicles in. And one of my favorite things is, so you want us to detect foreign objects? Yep. Do you have a bone problem? No. They did. Especially every 2 weeks, they were doing a maintenance and something wrong was happening. Every 2 weeks, bone instances went through the roof, and we instantaneously were able to show them a plot like this and say, hey, maybe you have to modify your maintenance schedule, and maybe you need to figure out what else is going on wrong. So this combination of imaging, hyperspectral, machine learning and intelligence is now giving us tools to provide you with information real time, show you statistics, classify materials, and you can say, this is my problem, this is my supplier's problem, and my customers are not getting any foreign materials. And this is what typical stuff we find. So with that, thank you so much for your time, but I'd love to answer questions. And which booth are we in? C13069. Happy to talk. And we have a machine for the first time ever. It is cool and you can throw crap at it.